right, great. It's like, yeah. And we're back to math. Here we go. All right, 4.1b. We're going to do chain rule a little bit. We'll practice some more because some of them are going to be harder even yet coming up. But we're also going to do parametric derivatives. Do you remember what parametrics are? Oops. Parametric derivatives. Yes. Parametric derivatives. Okay. Now, here's what a parametric function was. We did this in the first chapter. It was x was some function of t, and y was a function of t. And remember, on your calculator, you have parametric mode. And so you don't have to graph functions. You could graph whatever you want. We graphed all kinds of stuff on there. Well, the derivative of parametric functions is actually pretty easy. All you do is this. You take the derivative of the x part of it, the x function, f prime of t. You take the derivative of the y part, f prime of t, okay? And then what you do is you just, to find dy dx, because that's what the derivative is, dy dx is just the derivative of y over the derivative of x. And so it's going to be, oh, why did I write f? I'm sorry. Let's change that real quick. This should be g. They're different functions. There we go. Ugh. It'll be all right. I just noticed that because I was thinking f prime of t over f prime of t is going to be 1. All right, so you take the derivative of the y function, which is g prime of t, over the derivative of the x function, which is f prime of t. That's it. They're different. They're different. I'm sorry. Yeah. I have it on my paper. I don't even know why I wrote it like that. So let's do one, okay? Let's go ahead and look at one, see what we're going to do. So number 1. All right, it says here that we need to find the derivative dy dt, or I'm sorry, dy dx, not dt. Find the derivative dy dx of this parametric function. X is equal to 2t squared minus 5, and y is equal to 3t plus 1. Okay? And we need, yeah, it's really that easy. You really just, you find the derivative of y, find the derivative of x. Perfect. Yep. So dy dx would equal the derivative of the y function, which is, yep, you guys said it, 3 over 4t. Perfect. I know. Isn't that nice?
Do we have to put the dy over dx? And what did we just find?
No. We just found the derivative of the parametric function.
Okay.
Yeah. So we're going to add on to that, though, because then they're going to ask you to find the equation of the tangent line at t equals 1. No, this is like the second part of it. So that could be, A would be find the derivative, and B would be find the equation of the tangent line. Yes, you're going to plug in 1 pretty much everywhere. Yeah. So in order to find the equation of a tangent line, you need a point and you need a slope. So let's work on our point first. We need an x, y coordinate. Exactly. You're going to use the original equation. So we want to find out what the xy point is at t equals 1. So you'll take 1 and plug it in. So you get t squared is 1 times 2 is 2 minus 5 is negative 3. Then take t equals 1 and plug it into the y part of the parametric function. So 3 times 1 is 3 plus 1 is 4. And then the slope is found from the derivative, right? Yeah. So plug t in and you get the slope is 3/4. Nice, huh? It's putting everything all together. You find your point, you find your slope from the derivative, and then you can just put this into point slope form. So y minus 4 equals 3/4 x plus 3. And that's the equation of the tangent line. All right, we're going to do one more of these parametric ones, and then we'll practice some more of the chain rule, just a couple. I don't want to go too long today. Okay, so this one's going to be a little trickier. So suppose that we have x equals secant t and y equals tangent t. And we want to find the tangent, or the equation of the tangent line. Different tangents, isn't that weird? Like there's a trig tangent. Yep, derivative always gives you slope of the tangent. All right, we're going to find the equation of the tangent line, different than trig tangent, at t equals pi over 4. So here comes your trig skills that I taught some of you, that Mrs. Pfeiffer taught some of you. Oh, and Mrs. Cowie. Miss Cowie taught some of you. Yeah. Okay, here we go. So we need to find the equation line of the tangent line at t equals pi over 4. So we're going to need a point and we're going to need a slope for all of this. So first let's go ahead. Let's just find the derivative first. So dy dx, the derivative of y, the derivative of tangent t is what? Secant squared t. You should really write t.
Oh, yeah.
Yeah. Secant squared t over the derivative of x would be?
Secant tangent.
Yes, secant t tangent t. So they're all in the variable as t. And then what you can do is you can fix this up a little bit. So one of these secants reduces, leaving you with secant t over tangent t. But we can actually reduce that, like fix that up a little bit too, because secant is 1 over cosine, and tangent is sine over cosine. And do you remember what to do when you have fractions over fractions? Yeah, you take the bottom one, and you, instead of dividing, you multiply by its reciprocal. So you get rid of that, and you multiply by, oopsie, cosine t over sine t.
Cosecant?
Yeah. And so the derivative, dy dx, is simply cosecant t. Whew, that's a lot, huh? A lot of trig there. Did you like it? Did it remind you of last year? Sadly. Okay. All right, so now we need to find a point, and we need to find a slope. So our point is going to be found by going back to our original parametric function. So what was x? X was secant t. So x is going to be secant, and what's t? We're doing this at t equals pi over 4. Do you remember what secant of pi over 4 is? Probably not, huh?
2 over 2 pi.
Kind of, yeah. Okay, so let's think about what cosine of pi over 4 is instead.
2 pi over 2?
Not quite. Rad 2 over 2.
Oh, yeah, that.
Rad 2 over 2. Do you remember that? You remember the unit circle?
I have the proof.
You do? That's so good. So then, you got to take the reciprocal. So 2 over rad 2, which is multiply top and bottom by rad 2. 2 rad 2 over 2, which is rad 2.
That's x?
Yes. Beautiful, huh? So x is rad 2. Isn't that nice? Should I go through that again? So cosine, hold on for some people. Cosine of pi over 4 is rad 2 over 2. But we want secant. Secant's the reciprocal, so we flip 2 over rad 2. We multiply top and bottom by rad 2 over 2 and get 2 rad 2 up top. Rad 2 times rad 2 is 2. The 2's reduced, leaving us with rad 2. All right, y is equal to, what was it, tangent of pi over 4.
Is 2 rad 2 over 2 rad 2.
Which is
2. 1.
1.
Wait, what is it again?
Okay, so tangent,
What I mess up on.
you do, this is the nice one, because here you are.
Yeah, I see it now because you flip it reciprocal.
So this is rad 2 over 2, rad 2 over 2, right? Tangent of pi over 4 is sine over cosine, which is just rad 2 over 2 over rad 2 over 2, which is 1. Tangent of pi over 4 is always 1. Okay, so we have our point. Rad 2, comma 1. Now we need, now we need our slope. our slope comes from the derivative. The derivative is cosecant of t. So the derivative is cosecant of pi over 4. Well, we already found it, right? What was secant of pi over 4? Rad 2, right? Cosecant is going to be the exact same because sine and cosine are the same here at pi over 4. So secant and cosecant are also the same. So that would just be rad 2. Okay, now let's put this into point slope form. Here we go. Y minus 1 equals rad 2, x minus rad 2. And you can actually clean this up. It turns out pretty nice. Y minus 1 equals rad 2x, distribute, minus 2, add the 1 over, so you get y equals rad 2x minus 1. I might have just let you keep it in point slope form. That would have been fine. Cosecant of pi over 4? Sure. So what is sine of pi over 4? Sine of pi over 4 is rad 2 over 2. Cosecant is going to be the reciprocal, and we already did the reciprocal for that. It's the same thing. Yep.
What? Now you just confused me. Sorry.
So that's okay. Sine of pi over 4. Oh.
But you put the answer as rad 2, but you have.
Because she has to rationalize.
I still have to rationalize it. Yeah, but she got it at that time, so I stopped.
Okay.
I shouldn't have stopped. Can't stop, won't stop. There you go. Don't let the trick stuff get to you, man. That's last year's stuff. You got to review that, huh? That sucks.
Yeah, I got 49 on that final.
Oh, no, you didn't. Shh, let's not say that. Okay, let's do a couple of just chain rules that are going to come up, some harder ones, okay? So let's do this one.
B then?
We could call this part B if you'd like, yeah. All right, so let's do something like y equals cosine x over 1 plus sine x squared. Okay, so we're done with the parametric stuff. That was pretty good. We're just going to do some practicing chain rule. So when you have chain rule, you might have product rule. You might have quotient rule. You might have, yeah, did a Christmas tree just go by?
Yeah, it did.
That was so random. Okay, so here we go. Here's our game plan. We have 2 functions here. That's it. It looks like more than that, but it's just 2. Okay, we have our outer function of the power of 2, and we have our inner function of that whole thing, but that's going to be quotient rule. So here we go. The derivative is, start with the outer function first. Bring the 2 down to the front, leaving you with cosine x, 1 plus sine x to the first power. You subtract 1 off. Times, and now here comes quotient rule. Are you ready for it? It's going to be pretty big. Here we go.
It's still going to be squared, right?
Yeah. Well, no, we're just doing the inside. The bottom will be squared. We're ignoring that square. We already did that part. Yeah. So low d high. So 1 plus sine x times negative sine x. Good. So low d high minus high, which is cosine x. D low, the derivative of 1 plus sine x is cosine x over the square of what's below. 1 plus sine x squared. All right, so you're going to need to fix this up a bit. So here we go. We've got a 2. I'm just going to leave this alone for right now. I don't really need that to the 1 power, so I'll just drop that. Up here, I'm going to distribute the negative sine x in. And I'm going to get negative sine x minus sine squared x minus cosine squared x all over 1 plus sine x squared. Yeah. You can pull out a negative 1 from those, like negative sine squared x minus cosine squared x equals negative 1. Wow, and then you have a negative 1 up top. Wow, there's a lot to go. Here we go. 2 times cosine x over 1 plus sine x. Up top, this equals negative 1, this whole thing. And then I can pull out a negative 1 from that. Factor out a negative 1 here. And when you do that, you're left with 1 plus sine x. And it's still over 1 plus sine x squared. And we can simplify that too. Okay.
Yeah, I don't see where you got the 1%.
No? All right. Right here, this part, what you can do is this. You can pull a negative 1 out of the whole thing, and you get sine x plus sine squared x plus cosine squared x.
Oh, it's just 1.
And sine squared x plus cosine squared x is just 1. It's a better way to look at it. So everything has a negative, 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 negative. And I pulled the negative out to the front, which left me with 1 plus sine x. All right, so let's keep going. We have some reducing to do. There's one of these here, reduces with one of those there. And that's pretty much, we're done. Okay.
Now it's just negative 2 times cosine.
Negative 2 cosine x over 1 plus sine x squared. Yeah, there's a negative 1 that we pulled out. I know, it's the algebra, huh? It's the algebra that's tough here. Okay, let's just do one more. I just heard the 7-minute bell, so let's do one more. Let's do y equals 5 over the square root of 3x plus 1. All right, for this one, a lot of people, once again, will think you're going to have to do quotient rule and chain rule. You actually don't. You will have to do chain rule, but you're not going to have to do quotient rule. So you can rewrite this. The square root of 3x plus 1 on the bottom can be rewritten as 3x plus 1 to the negative 1/2. Right? You agree with that?
Yeah.
And since 5's a constant, you don't have to do product rule here either. Okay? So let's go ahead and let's take the derivative of this. You move the negative 1/2. There's an out. Let's talk about that real quick. Our game plan. There's an outer function of a power of 1/2. There's an inner function of 3x plus 1. So take the negative 1/2 and multiply it to the front. So negative 5/2, leaving the inside alone, and subtract 1 from negative 1/2, so you get negative 3/2. Times. Now take the derivative of the inner function. 3. Perfect. Okay, you cannot leave it like this. I'm sorry. But there's going to be some fractions. You can't leave negative exponents. So up top, we're going to end up with negative 15. This negative 5 times that positive 3. On the bottom, we have a 2 in our fraction, and we're going to take that and drop it down. Now, some teachers are picky. I don't mind you leaving this as to the 3/2. Some people want to write it as the square root of 3x plus 1 cubed. I'm fine with that, okay? And that would be your answer right there. All right, so I've given you